Hello, this is Mr. Wynn, and this video is about parent functions and transformations. So parent functions are the simplest type of function from each family. They consist of a single variable and a unique function identifier, such as an exponent or square root symbol. Because they have no modifier, such as a constant being added or subtracted, or even a multiplier, they're the closest to the origin 0, 0. In fact, most of them go through 0, 0, as you can see. Here's a list of common parent functions and how they look. You should already know the attributes and characteristics, such as the domain, range, and the vertex or starting point for most of these. If you don't know, then start setting up, but it should come back to you. So when you know their parent functions, it is extremely easy to sketch transformations of them and figure out key characteristics and attributes of the new function. Transformations are modifiers, such as a constant being added or subtracted, and even a multiplier. Given a function f of x, here are the four types of modifiers. You have a in front, then b on the inside, minus h on the inside, and plus k on the outside. Alright, a is the outside multiplier that does not directly affect x. It's not on the inside of these. Outside means no change ever. If a is negative, the graph will be vertically reflected across the x-axis, meaning it's going to be flipped upside down. If the magnitude of a, meaning the absolute value of a, is greater than 1, we don't care about the sign because the negative is just for the reflecting across the x part. So if a is bigger than 1, even if it's like say negative 9, we say 9, the graph will be vertically stretched. If that magnitude of a, the absolute value of a, is less than 1, the graph will be vertically compressed. So if you think of a ball, and you're vertical, you're in the bottom and top, if you stretch it, that means you're pulling it, it gets taller. But if you're compressing it from the top, like squishing it, it's going to get wider. Alright, b is similar. B is the inside multiplier that directly affects x. Now if you're inside, you have to think opposite. So b is kind of complicated. If b is negative, the graph will be horizontally reflected across the y-axis. It means it's going to be flipped sideways. Alright, so multipliers always do reflections if they're negative. Now here's the opposite part. If b, the absolute value of b, is bigger than 1, you actually will have the graph being compressed horizontally. So earlier, bigger than 1 means stretch, but now bigger than 1 is compressed, and this is horizontal. Alright, if absolute value b is less than 1, earlier smaller than 1 was compressed, but now it's going to be stretch. Alright, now if there's a multiplier outside or inside with x, you must factor it out to get b and see the real h. So basically when b is there, you have more work to do. So don't forget that. And then when using words to describe b, you must make b a fraction and then flip it and then use that number. For example, if b was 1 over 5, you'd flip it to say 5 over 1. If b was a fraction 2 over 3, you'd flip it to say 3 over 2. Alright, h is inside as well, and it's a constant that's being added or subtracted that directly affects x. Alright, inside again means think opposite. So if h is being subtracted, although subtracting usually means left with negatives, you actually will move the graph right. And if h is being added, the graph will actually go left. And for k, k is outside constant being added or subtracted. It does not affect x, so outside means no change. If k is being subtracted, that's just down like normal. And if k is being added, that's up like normal. Alright, so the outside things, a and k, only affect the y, not the x. And they're the vertical control. The inside, b and h, those are the horizontal control, but they do affect x, so you have to think opposite. Alright, let's try some examples. So the a, b, h, k transformations apply to any and every type of function, even non-parent functions. But for now, I'll use quadratics to demonstrate. So first, let's look at x squared compared to negative x squared. Now, this is the negative here. That's the only difference. Now, is this the a, b, h, or k? Well, it is a multiplier in front, and it's not part of parentheses. So it's just a. If a is negative, the graph will be vertically reflected across the x-axis, or again, basically flipped upside down. So here's that graph. Here's x squared parabola. Here's negative x squared. It's the same parabola upside down. Alright, the next one. X squared compared to 1 half x squared. So now a is positive, so we're not, let me move this. There you go. So same graph, but reflected over the x-axis. So same graph, but or same equation, but now we have 1 half in front. It's not negative, so we're not going to reflect it like before. But since a is smaller than 1, small means vertical compression. Alright, so it's going to be the same graph, but vertically compressed by a factor 1 half. So when you compress something from the top and bottom, you're squeezing it, it's actually going to get wider. So let me show you that graph. So see how it's sideways more? Alright, this next one. X squared to 9x squared. Well, now a is 9. Not negative, so no flipping. But a is bigger than 1. Bigger than 1 means stretch. The bigger the number, the bigger the stretch. So this is going to be the exact same graph, but vertically stretched by a factor of 9. So here that is. So see, it's skinnier and taller because we're pulling it from the top and bottom. And of course, you can do a combination. You can make it a negative and 9 together. Again, the negative is one thing. It reflects the graph over the x-axis. And then the 9, the magnitude is different. That's bigger than 1, so it's going to be vertical stretch. Some kids say Oh, negative 9 is smaller than 1, so does that mean compression? And the answer is no. We're looking at the absolute value, the magnitude, just like the number. The negative is reflection, the number is stretch or compress. That's it. So if I show you this, it's going to be the same picture, but upside down now. So it's skinnier. Alright, let's go to the next one. So these are all A's. So let's now look at B. Looks very similar, but now it's in parentheses. Alright, so B controls the horizontal and it's opposite. So if B is negative, we're going to reflect it, but instead of across the vertical axis, the x-axis, we're going to reflect it sideways across the y-axis. It's the same graph across the y-axis. So here's that graph. X squared compared to negative inside x squared. You know a negative squared is positive, right? So exact same thing. You just change colors. Now, going back to this, it's actually not too easy to see a reflection across the y-axis because the quadratic is very symmetric. So I'm going to show you a square root graph and to make it more obvious. So here's a square root graph. The green line. If I put a negative on the inside, that means B is negative. It's going to flip to the other side, to the left. See that? Alright, so that's what I mean by it's a reflection across the y-axis. Alright, let's look at the next one. 1/2 on the inside now. Again, this is B, not the same from before, because this was A on the outside. This is inside. This is 1/2 all squared. So if B is 1/2, that's smaller than 1, but I think opposite. Smaller usually means compression, but for B, it's going to mean stretch. And again, B is horizontal, so it's going to be horizontal stretch. And you have to flip that fraction around. So it's going to be horizontal stretch by a factor of 2. So I look at the graph. Here it is, horizontal stretch. So you're at the sides now, but you're pulling on the sides. So that'll make it more sideways. You see that? Now, think about this. I could actually get rid of that parentheses. If I do 1/2 squared, I get 1/4. So here's the exact same thing without parentheses, right? If you look at this, that means we have A value, no B value. So if A is 1/4, that means vertical compression. Does vertical compression mean the same thing as horizontal stretch? So if you squish it from the top and bottom, is that the same thing as like pulling it sideways from the sides? And the answer is yes. Alright, let's try the next one. X squared to 9x squared. This is B. B is 9, but I think opposite. So I'm making instead of stretch, I'm going to be horizontal compress by 1/9. So I'm gonna push it inwards like that. You see that? I'm gonna squish it from the sides. So, like I said, horizontal compress by 1/9. Now I could also get rid of the parentheses and just square it, and I get 81x squared. That means the A value is 81. So does vertical stretch mean the same thing as horizontal compress? And the answer is yes. It's just a different factor. Alright, so if I pull it from the top and bottom, it's the same thing as squeezing it from the sides. Alright, and then the combination, B is negative, so we'll flip it sideways. So it reflects across the y-axis. And 9, bigger than 1, but opposite, so it's going to be really smaller, so it's going to be compression, horizontal, by the flip fraction, 1/9. Alright, horizontal compression, 1/9, reflect over y. So we're going to see this. Alright, here's the next one. Alright, so now we're talking about h and k. So x squared compared to x plus 5 on the inside squared. Because it's inside, it's h, but inside means opposite. So I would say plus 5 and think minus 5. That minus means left. So it's going to be the same graph, but move left 5 units. So here you go, right here. X squared compared to x plus 5 squared. So it's the same graph. It started from 0, 0, but now went to left to negative 5, 0. Alright, so to x minus 3 on the inside, minus on the inside, that's h. Opposite, so it's really plus 3. Plus 3 means right 3. So if I turn this off, turn this on, it's the starting picture. The parent function, just write 3 units. Alright, now this is plus 5 is on the outside, not in the parentheses anymore. So this is a k. K is just up and down normal, don't change it. And k is just up and down, so this is going to be the same graph, but up 5. So let me show you that. Here you go, from 0, 0, it now starts at 0, 5. And the last one on this, minus 3, that's still k. K is normal, so minus means down 3. So here's this one. Alright, so hopefully that helps you figure out A, B, H, K. Now let's try some harder ones. Here's up A, H, and K. So let's think about this. X squared to all this. Well, first what showed up, A showed up as negative. If A is negative, we reflect it across the x-axis, upside down. Then 4. Alright, not negative 4, positive 4. 4 is bigger than 1. For A, that's normal. It's the vertical stretch. It's a vertical stretch by factor 4. By the way, when you ever say a stretch or compression, doesn't matter if it's horizontal or vertical, it's always by a positive number, never a negative. The negative is only for the reflection part. Inside this minus 7, that's h. I think opposite, so it's going to be right 7. And then outside is plus 5, so that's going to be up 5. So if I think about this, let me show you. It's this first graph right here that we have, right? And first thing we do is flip it, right, upside down. Then we're going to make it vertical stretch, make it skinnier. Then it's 0, 0, skinny, but we're going to move that 0, 0 right 4, sorry, right 7, and then up 5 to get this starting point 7, 5. So all that does make sense. All right, this one without graphing. So A is 0.25. It's not negative, so no more reflection. But less than 1, smaller than 1 means compression, and that's A, so it's vertical. Vertical compression by 0.25. Inside's plus 3, that's H, but it's opposite, so it means minus 3, left 3. Then outside's K minus 1, that's normal, so minus means down 1. That's there. All right, here's some harder ones, BHK. Now, if you compare these two, a lot of kids think right away, oh, look, minus 6 means right 6, and oh, look, B is negative 2, but that's wrong. So actually, I'm going to do this. I'm going to show you the picture first, and then we'll talk about it. It's not going to be right 6. So here's the original, here's the new one. Look, it went to, what is that? Negative 3, negative 2. So that's not left 6, or even right 6. So let me show you how they got that negative 3. So first, if you have B, actually you have to factor. So we're going to take out that negative 2 to everything on the inside on the parentheses. So if I take out negative 2 of this, negative 2x by negative 2 is just x. Then negative 6 divided by negative 2 is positive 3. And it's still in the parentheses, we're not square it yet. Then everything else stays the same. Now we work on this. There's no a. B is negative. Negative means reflection across the y-axis. And 2 is opposite those. I'm listing 1/2. So it's going to be horizontal compression by 1/2. Because I had to flip the fraction. Then inside's plus 3, that's H. That just means left 3. That's where the negative 3 came from. Then outside K minus 2, that means down 2. Alright, so if you look at this graph, you see that it went left 3, down 2, and it was horizontally compressed. It's squeezed from the sides. That's why it's taller. Alright, this one, same idea. Don't say right 3 because we got to take it as 1/3 first. If we factor out that 1/3, and yes, it could be a fraction. 1/3 x divided by 1/3 is this x. And then negative 3 divided by 1/3, hopefully you know how to divide fractions. But you get negative 9, and then outside stays like that. No a. B is 1/3. So it's not negative, so no flipping sideways. But I have to think opposite. So although less than 1 usually means compression, this is going to be stretch. And then I have to flip it too. So 1/3 to 3/1. So horizontal stretch, 3 by 3. Then this minus 9, that's H, that's right 9. Then K plus 4 means up 4. Alright, and of course you can have all 4 at the same time. So why not? Here's the equations. Let's take care of this B first, this negative 4. Because I can't, this is not left 7. I have to factor out this negative 4. So once I do that, I get this. So outside stays the same. Take out negative 4. Negative 4x by negative 4 is positive x. Then positive 7 divided by negative 4 is a fraction of negative 7 4. So you can have fractions inside. Now we go in order. The negative in front for A, that means flip or reflect over the x-axis. Then 8, that's more than 1. Vertical stretch. Again, that's A, it's normal, don't change anything. Then we go inside B. Negative means reflection over the y-axis. And then positive 4 usually is stretch, but I'm thinking opposite because I'm inside. So it's going to be horizontal compression by, I flip this to make it 1/4. Then inside the H, that's actually plus 7/4 because it's right into the negative. And then outside K plus 3, that means up 3. Alright, last slide. Let's try comparing some non-parent functions. If we have x plus 6 on the inside squared and compare it to x minus 2 on the inside squared, it's pretty simple. All you need to do is find out how much each transformation modifier changed. So there's no a change, no b change, no k change. Only h, the inside part, change. It went from positive 6 to negative 2. Well, to do positive 6 and negative 2, you have to subtract 8 minus 8. So if you subtract 8 for h, that means you go right because h is opposite. So let me show you this graph. Right here, here's x plus 6 squared, and then there's x minus 2 squared. So it started from negative 6, 0, and it went, the new one started at 2, 0. So the whole picture went right, 8. Alright, then here's a harder one with a lot more things, but it's the same idea. Look at A, h is from 2 to negative 8. So you have to multiply by negative 4. There's no change in B. H changed from negative 1 to positive 4. That means you have to add 5. Again, that's your H. Then K changed from positive 4 to positive 1. It went down, so you subtract 3. So for negative 4 for A, that means reflection across X is negative. A is 4, so that's vertical stretch, greater than 1. H, add 5 means opposite, left 5. And then K, subtract 3, that's normal, that means down 3. And that's it. Hope you enjoyed the video. Make sure you ask questions. Thanks for watching. Bye.